Welcome to the On-Premise IT podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth and I am a part of Gestalt IT, and each episode we bring you the viewpoints and opinions of a group of IT luminaries from across the enterprise IT space. I'd like to take a moment for our panelists to introduce themselves before we jump into the topic for today's episode, the premise, if you will. Starting with Chris.
Hi, I'm Chris Reed. You can find me on Twitter at @thecmreed, and I do Wi-Fi stuff.
My name is Troy Martin. You can find me on Twitter at TroyMart. I deploy all types of wireless networks, and my favorite BSS color is aquamarine.
Sean Neal, Twitter handle SV_Neal. Also do a bunch of networking and wireless.
Thank you all very much for joining us today. Now, as you've probably guessed, if we have a panel full of wireless experts, we're probably going to be talking about wireless today. You are very familiar with the technology. Everyone uses it on a regular basis to connect to a variety of software and services that help our daily lives. But what happens when the chips are down and it absolutely has to work? What are you going to be relying on to make sure that you can make that call to emergency services or look up how to perform CPR on someone? What happens if the connection between the device and the rest of the network is the difference between life and death? Well, that would be something that's very mission critical. And the premise for this episode is that wireless is not mission critical. Now, we've had a lot of discussion here around Mobility Field Day about some different kinds of wireless and how suited they are to be doing mission critical applications. So I want to throw it out here to the panel. Do you think wireless is mission critical?
So I think there's a lot of different applications that we can look at and use cases that we have. And depending on the requirements of those use cases, that's how you can evaluate your technology to make a decision or a conclusion to whether or not that use of that technology applies to your mission critical. So for example, in retail space, if you have a wireless only deployment for your retail space and the wireless goes down, that becomes a mission critical application if you can't collect payments from your business customers. But I do think that we'll need to differentiate mission critical versus safety related versus safety control at some point in this discussion.
So what you're essentially saying is there's even different categories of mission critical. There is, I can't do the function that I am assigned to do, or people will die if this doesn't work. Like, it's the difference between not being able to sell airline tickets and what happens if the airplane falls out of the sky. Mm-hmm. So there's different phases of mission criticality, which I would say is probably accurate. But is that something I need to think about when I'm just plugging an access point into the wall and getting my computer on there?
Yeah, I mean, you've got to decide on your application and whether that's mission critical, and then deciding what transport it needs to take that aligns it with that level of risk for it. So ultimately, when we talk about wireless and we talk about Wi-Fi, that Wi-Fi is an unlicensed spectrum, but we can talk about cellular technologies and being in a licensed spectrum. So you've got a lot more control over the transport, and that's a more reliable medium than an unlicensed spectrum.
So we're getting into a little bit of a terminology difference, because I would expect that a lot of the people who might be watching this episode, if they're not well versed in the industry that we refer to kind of generically as wireless, might think that all wireless is the same. But as you mentioned, there's licensed spectrum, there's unlicensed spectrum, there is wireless that may be like maybe 5G, LTE, something on your phone that is traditionally considered like carrier, or Wi-Fi, which is a subset of those technologies that is very strictly defined by the Wi-Fi Alliance. So in your sense, if you will, some of those things are more well suited for very critical applications. Some of them are not. What would you say would be a good use for a licensed spectrum?
So licensed spectrum, you own that airspace, and you've got supporting bodies that will help you if someone is infringing upon that airspace. So the stuff that is absolutely has to be there, the making sure the plane doesn't fall out of the sky kind of stuff, that's really well suited for licensed spectrum, where some of the, I would say, business critical applications that they could operate on things that are unlicensed, there is a lower level of risk to that. And you're making trade-offs sort of across the board on all of this, that there's pros and cons to all, to your decision on transport. But some of the more business-focused stuff that can operate on things like Wi-Fi or on things like LoRaWAN or other options for IoT.
I think it's interesting to see too, as technology evolves, I think we're being asked to continually reevaluate some of that too, right? So, for the people who are watching Mobility Field Day 7, for instance, right, we just talked a lot about private 5G and what enterprises are trying to do there, right? And so that's a different category. And it seems to be that pretty collectively, the focus of these private 5G companies is going after a few things where, to your point, that spectrum needs to be protected in some way, whether that's a limited use or a fully licensed spectrum. And they're trying to make cases like Wi-Fi is not good enough to handle these. Trust our licensed spectrum for these specific use cases, whether that's something that might be life safety on a manufacturing floor, or something like that. So.
Yeah, I mean, it's all about, in that scenario, it's all about picking the right tool for the job. That when you've got those life safety stuff, that looking towards light licensing, towards licensing, you've got more control over it across the board. Where Wi-Fi for a lot of devices, it works well enough. And I built my career on Wi-Fi. I love Wi-Fi. There's a lot of great things about it, but it has a set of things that is very suited to, and you don't want to make Wi-Fi do something that it isn't well suited to.
Yeah, and somebody mentioned, sorry, I forget who, but yeah, as you watch this, I think we are seeing the different PHYs evolve, right? The different transport layers that fall under the broad category of wireless, and there are definitely some that are, very much behind the scenes that, and the IoT things, for instance. And I would also argue that there's some stuff there that in certain scenarios, certain environments may be considered mission critical because they are tied into things, and they might not run on the licensed spectrum. So if there's monitoring, certain aspects of a business or like a plant or something, there are some things that, might not be licensed that are still pretty important,
So, we just need to be cautious that we talk about licensed versus unlicensed and how you can own licensed spectrum. Just because a company owns a licensed spectrum doesn't mean a bad actor can't emit signals that block or interfere with those transmissions, right? So if you're working at a refinery or a nuclear plant or some sort of energy generation plant, you could face attacks where people come in and compromise your licensed or unlicensed spectrum by the signals that they can transmit. So you talked about risk, and I think that's the big thing to consider as you sort through these protocols. Are you doing enough to mitigate the risks for the effects that could happen if that network's communication got compromised?
So I actually want to pick up on that point because that's something that I think maybe people need to understand. Is it something about the protocol itself that inherently makes it less reliable for being a mission critical app, or is it something that I hear a lot, which is, in the unlicensed spectrum, you never know who your neighbor is, and they could be super noisy. And we've all heard the stories of how, the 2.4 gigahertz band is effectively trashed at this point, and even 5 gigahertz is being overloaded, and all of these other things. So is it the protocol, or is it the fact that so many people are using it now that we have effectively ruined it for ourselves to be able to make it stable and reliable?
It's both to some extent. The cellular technologies, LTE and 5G, that at their core, it's more scheduled, and they've got the ability to do things like roaming incredibly well because it's all tightly scheduled. Whereas Wi-Fi, we run into more interference in those because it is unlicensed. There's just a ton of garbage there. But the PHYs are contention based. So you have to roll the dice essentially for every transmission. So it is both.
I do think it's interesting. You mentioned those different PHYs and as I move something up in terms of my prioritization of it in terms of criticality, right? There's a lot of system too that I think you do want in place, and we talked a lot about troubleshooting tools and things like that today too. There's got to be a question out there can I prioritize something as mission critical and put it on a licensed PHY if I'm blind to how that PHY works?
I guess it depends on part of how much detail do you need to know about it working versus understanding high-level concepts. So just to contrast with Wi-Fi, we have other wireless protocols that are out there that can have multiple connections to access points or to the infrastructure and send duplicate packets along different flows. Those duplicate packets could go out at the same time in some protocols, or they could be sent at different times, taking different paths through the network. In Wi-Fi, we often make fun of mesh networks or use that as a last resort. In the IoT world, the bigger the mesh you build, the more resilient and robust that network gets because there's more paths that you can take using different channels and different times to send those frames back, which gives you more reliability for those mission critical applications.
I think you bring up an interesting point there because there are a lot of people out there that want things to be ultra reliable. They want everything to just work no matter what. And as people who have been heavily involved in design and engineering, when you come to me and you say this can never go down at all for any reason whatsoever, what do we usually come back with? We come back with a design that has duplicate devices, that has protocols running to ensure that. Greg Farrow, a friend of the show, is notorious for saying, when I tell you to buy one, I really mean you buy two. Because you need to have a primary and a secondary. You need to have the one that works and the backup. However, when we start getting into these cost discussions, that's usually where the things change, because now when you tell me that this needs to be a mission critical software application or a mission critical function that absolutely has to work every time and that it can't ever be interfered with, and it can't do this and it can't do that, and your response is, okay, well then we need to license the spectrum and we need to use this technology and this hardware, and here's the bill, and after that person picks their jaw up off the floor, they're like, well, can we do it for like, I don't know, half of that, less than half of that? And you're like, well, no, because like we have to allocate the spectrum and purchase it from it. Well, what if we just used Wi-Fi, because that's cheap, right? Well, you're going to lose all of these functions and all this other stuff. But how bad could it get? And so now we're playing the game of the lofty pie in the sky goals of making sure it never goes down versus the Snickers bar budget. And it's like, well, where can we find the happy medium in the middle? So is there a situation where you could provide reasonable assurance on a technology that is perhaps not the most expensive solution, which therefore means it may not be the best solution?
Absolutely. If it absolutely has to work and you want a low cost for it, you wire it up. And I think none of us would disagree with that.
As an old school wired guy, I'm totally fine with that because Ethernet cables rarely have weird problems. Not saying they never do, but when it all else fails, we plug it in with a Cat 5e.
So I would push back on that. In some scenarios, you can't wire it in. So situations where you have turbines or motors, generators that are spinning in motion, you can do coupling and transfer information through that. But wireless, some form of wireless becomes the best mechanism for those types of environments.
But again, you run into the problem of, I want it to never fail, but I don't want to pay for never fail. So can you create a system that is 80% as reliable as the never fail solution and just help that business accept the risk that there may be a window where it doesn't work?
I'd argue that is what Wi-Fi is right now. So I think Wi-Fi is any Wi-Fi network is sort of a compromise of the worst devices that are on it, right, that you have to support, blended with, the applications and everything else that you're trying to do. And so I think, as an industry, the answer seems to be that no, like Wi-Fi is not quite good enough to answer all that, but it has been the answer so far. And so now we're starting to evolve and we're starting to look at, on the one side, it's the things like the IoT, the Bluetooth, the Zigbee, the LoRa, those types of things that are low bandwidth, meshes that can be highly reliable. And then, on the other side, we have these applications that we're looking to try to push towards licensed spectrum to protect them. And so I think we are starting to say as a industry that Wi-Fi by itself is not enough, but I think it had been that answer. It again comes down to that application and use case driven is that when we talk about that 80% or 90% that we can talk about resiliency and redundancy there. If it's let's say it's a Zebra scanner, well, we've got options to have that connect via Wi-Fi.
and via public cellular and via private cellular, you'd come to, you're going to have a lot more problems if all of those are down at the same time than whether you can scan or not. So you can take that and not make a decision that I need to settle on one wireless technology. Let's settle on multiple wireless technologies, and when one of them isn't doing what I need it to do, I can fail over to a different one.
So actually, that's a really good point, because we talk a lot about the way that these technologies have evolved. And I know, especially in the case of something like Wi-Fi, there was a very strong direction in the way that it needed to operate. But it needed to be different than what we already had. Things like traditional like AM, FM radio, or other kinds of communications like satellite uplink, downlink. And part of that came into the fact that they did not want to have a system that required these enormous base stations to be able to receive these signals. I mean, I'm not going to put like the Arecibo dish in my backyard, as much as my wife might like that. But the technology dictated the way that we used it. It has to look like this because that's what the standard says. So these are the limitations you have to work with. And as we developed additional wireless technologies, not Wi-Fi, but things like IoT-focused wireless or private 5G, CBRS type stuff, we solved challenges that Wi-Fi had, which allowed us to develop hardware and software in different ways. Maybe IoT wireless doesn't need to be quite as robust and have a super amount of throughput, because I'm not as worried about a single station sending a lot of traffic, like a big packet. I'm more worried about the fact that it's super chatty, and I'm trying to run it off of a battery the size of a shirt button. So has our development of technology and the ability to have different kinds of wireless technologies out there, not just Wi-Fi, helped transform the way that we look at the fact that maybe this service can now be made more reliable and be relied upon more, because now we have a better connection mechanism for it to be able to do that?
I think Wi-Fi has exposed a lot of people to wireless. So they spent many, many years, decades now, connecting their devices to wireless infrastructure. And so like the flexibility, the benefit that it brings, and they're trying to expand that and move that into more verticals. And as they move into more industrial, manufacturing related processes, they're trying to leverage the cost benefits of wireless while still minimize the risks that involved if something goes down. And one of the big challenges they run into is latency. Right? Eventually with Wi-Fi, you can get the frame across. But if you need to get it there in a specific amount of time in a very short, low latency period, that's where the challenge becomes in those type of environments. So it's guaranteed delivery within that time frame.
And a lot of these technologies, and you were talking about the low data rate, that a lot of these, if you move that data rate down, it becomes a more reliable medium, because your symbol encoding doesn't have to be as complex. So you're more likely to deliver that packet just if you've only got a couple of them to send, and they're smaller, that'll get across very easily. But when you start to move the use cases towards video and audio and having that come in sequence, that's where we start to run into problems with Wi-Fi in particular, but other technologies as well.
Yeah, I think even as we take that further to the next step, I think we're talking now about the private 5G type stuff that's, I would need to be able to hit a forklift that's moving at 30 miles an hour, right? That's different than what we've done before. But if you go even further and start looking at things like wireless technology between multiple autonomous vehicles or something like that. I mean, you could have a situation where it's two vehicles passing each other on a freeway, and the delta between their distance, it could be like 150 miles an hour or more, right? And so I think some of those transactions are going to have to happen in certain ways that just have never been even possible before, and so it's going to have to continue to evolve, and we're going to have to continue to meet some of these demands, and we'll find ways that work probably, and then we'll find ways that are better, and just continue to evolve them to meet those applications and use cases.
But that vehicle-to-vehicle example that you're giving, that they're not relying only on that vehicle-to-vehicle communication to do things like preventing people from crashing into each other. They're using other systems as well to do that, and that's increasing the reliability of the overall system.
Yeah, 100%.
And part of that involves making sure that those systems have access to communications technology, but don't need to rely on it. Mm-hmm. So in a way, they found a way to take a mission critical system and build in effectively a fail-safe by saying, I don't need this to be connected to the internet to stop you before you hit a child. And I think that that's an important distinction, because we talk a lot about the fact that edge compute requires a significant amount of extra processing power. Well, why is that? Well, We don't want to run everything in the cloud when latency matters, when life or death decisions or even company bankrupting decisions happen in a matter of seconds. Can you wait for the latency to go out to your favorite public cloud provider and get the answer and come back? Oh wait, the moment's gone. I mean, we look at the fact that even like the stock exchange wanted to build a series of microwave towers between Chicago and New York for the Mercantile Exchange. Why? Well, because building direct microwave transmission towers saved 300 milliseconds on the round-trip latency over the fiber lines that they had laid, and 300 milliseconds on a trading platform is several $1 million worth of lost revenue. So people are relying on those, but of course, those were microwave towers, not Wi-Fi or 5G or anything like that. So in a way, some of the technology that we're wanting to adopt and develop is dictating the way our wireless and our communications protocols need to effectively behave, because we are a long way removed from, cool, my laptop doesn't need to be plugged into an Ethernet cable in order to get on the internet. And now we're looking at the fact that there are a lot of things that are built today that would never even, we don't need Ethernet ports. We would never even consider putting one on there.
But that's, again, letting the application drive that technology decision. In the edge compute example, that we're not moving all of your public cloud data over to edge compute. We're taking the specific things that are suited to edge compute and moving those to edge compute.
So you're a consultant. You're someone who is trying to have a conversation with someone, and they tell you, this is mission critical. It cannot fail. But here are your constraints. You must do it this way because it's the way we've always done it. How do you overcome those objections? What questions do you ask to that person to find out, A, is it really mission critical, or is it just this is my pet project and I just want it to be really cool? And B, what is the mission? Because I would argue that there are devices in a hospital that are way more mission critical than other devices that both fall under the umbrella of mobile healthcare. A system that's monitoring pulse ox is a lot more mission critical than a glucose monitor, which gets hooked up maybe 3 times a day. So how do you have that conversation with someone to help them understand that there's your version of mission critical and what mission critical really is?
So some of the questions that I would ask is, beyond the network connectivity, if that device failed or if you lost power, would a power loss take out that device's failure? Do you have more than one of those devices? So in a retail store, for example, if you have one payment system, that's your critical point of failure. If the Wi-Fi goes down or that device breaks or you lose power, you're done, right? So unless you're willing to address those other issues, you arguing that the Wi-Fi portion of it is mission critical is a little bit misleading. So there's some of those qualifications. Other things, in the industrial space, the information you're pulling back, you get extra sensor information. So pressure, temperature, flow rate, level alarms, vibration, all that kind of stuff. That could just be secondary information that you're pulling in that provides some business value to do some analytics, but it's not critical to the business process itself. It just allows you to make better business decisions for maintenance periods down the road. Where if the wireless network's being used to send instructions to shut down systems in the event of an emergency, that's where I'd argue that it becomes safety control related. And if anything blocks or disrupts that communication, that signal to shut down a process in the system, then there's significant ramifications of the communication not working successfully.
Yeah, I think you're highlighting a lot of what's the cost of failure, right? Mm-hmm. And what's the cost of mitigating that failure? Because there's some, it could be, if I'm a retail store, you might say, hey, this point of sale is absolutely critical, mission critical to us. But you may be able to push back, look, if it went down, worst case, maybe you can only take payment via cash. You send somebody to go to an ATM, right?
Well, and there'd also be mechanisms to possibly do an offline. So take that credit card information and then
restore it forward.
So then there is risk to doing something like that, where all right, someone might come in with a bad card,
right,
but overall your breakage across all that time that you're down is minimized. It's just whatever that breakage is.
Yeah. So I think going through that process, if someone's absolutely hey, this is absolutely mission critical. We want to do it the way we've always done it, but here's all your constraints. I think pushing back and really trying to help walk through that process logically to either poke holes in the constraints or poke holes in it being mission critical, one or the other. But I think working through that and then getting to a point look, if it costs $1 million if it goes down and the workaround's $10 million to fix or to mitigate, then it's a business decision is it or is it not worth doing? And I think at that point you decided, yes, it's mission critical, no, it's not.
And asking the questions to truly understand the constraints is the big one. Is if they're asking you to say, hey, let's talk Wi-Fi, that we need the APs to be underneath the kiosks. All right, why is that? Well, we don't want to see them. All right, we've got other options to deal with that constraint. That's not a constraint. Don't let that constraint drive a decision where we can overcome it in a different way.
And I think that's the most valuable point to bring up here, is that mission is how we accomplish our goals. It is the way we execute on what we're supposed to be doing. And all missions involve some form of risk. We can never have everything go perfectly every time. But the risk that we accept is different based on the mission that we do. If you think of a company like NASA, the mission of a janitor is much different than the mission of the Capcom or the people who designed the rocket. Some of them accept the risk that if there's a locked door, maybe I don't get my job done today. Some of them accept the risk that if I don't do my job correctly, people could pass away or something really bad could happen. But ultimately, it comes down to a question of how you choose to accept that risk. What defines criticality for your mission? Is it just that you won't be able to take payments in your store for a few hours while a big telco provider has an internet outage problem that's not really the wireless but still affects it anyway? Or is it if this system fails, people will die? You have to quantify that risk, and you have to be able to say with certainty that this is what I'm willing to avoid by paying for this. And maybe that solution is something as simple as a more robust Wi-Fi design. Maybe it's looking at other alternative wireless technologies. Maybe it's going to the point of effectively building your own base station to provide 100% reliable communication at a significantly increased cost because it's worth it to you to avoid that risk. But whatever the question is, you have to know what your mission is before you can decide exactly how critical it is and how much it's worth to you to be able to make it happen. That'll do it for this episode of the On-Premise IT Podcast. I want to thank everybody for tuning in. Remember that we do publish our episodes roughly once every 2 weeks. You can find the latest episode on our website at gestaltit.com/podcast. You can also follow along in your favorite podcast application of choice or subscribe to us on Apple Podcasts through iTunes. If you do that, though, please make sure to leave us a review and a rating because people love to read those and figure out that this is an enterprise-focused IT podcast that talks about premises, has a singular topic. And we will be back with another great premise with you very soon in a couple of weeks. But until then, thank you very much for tuning in.